Alright, in this video we're going to be using finchTV to look at a chromatogram. This is from the sequencing of our PCR product. So you open finchTV on your computer, alright, like this. Alright, and we're going to go to File and Open, and you're going to find your particular chromatogram that was given to you, and your result here is this mess. I would immediately go up here to the top and click to the one that shows the chromatogram in rows. You can scroll like this. Now what we're looking for here is we're looking on this to look for places that are good sequencing and bad sequencing. The sequencing typically at the beginning of any sequence sent off for sequencing, the beginning parts of it are usually bad, as you can see here. Alright, this is a mess. Sometimes you can look up here at this gray region. This is controlled by the boxes, the little buttons up here at the top. This is a quality, and so here this early region is very bad, so you can ignore that. It can be bad in the middle as well. Now you look down here at the bottom, the end should also be pretty poor. Yes, actually it's pretty bad for quite a ways. Let's see. It really doesn't start looking very good. Actually, this one doesn't look good very much. Very good at all here for quite a while. It's pretty good here. It's hit or miss in here. So some of this data is not going to be good, places where the sequencing was bad. Besides the beginning and the end, sequencing is also suspect wherever you have repeats, like whenever you have two T's, though here these are sharp peaks. That's good. What you don't want to see is something like this, where you have green and blue that are both high. The peaks are high. Each color here represents a different base, and as you can see, when you have a mess like this is bad. And you don't want anything, two things that are both high. These are probably not a T, which is red, and it's probably not a G, which is black, but it could be a C, which is blue or green here. So you really don't know. It says it's an A up here, but because these are both high and they're also close together, it says it's A, but you notice the gray part is missing altogether. It means it really doesn't know right there. When the peak is very clear that it's only one of the four, it'll give you a high peak. So this G and this C are both high, this C and T are high, and so what you want are these regular, like, mountains and valleys here going up and down, with the other lines being low when only one of them is high. That's a good read right there. But you get some bad reads, like here you don't know, and that's because they usually get the bad when there are two together. Here this was the G's, it's saying it's pretty good, so 3 G's in a row, but that's hard for the sequencer to do. They kind of blur together when you get two in a row. Here these two A's, not quite sure, but you look here and it says, well, everything else is low, so I'll trust that both of these are A's. So that's how you read this. Alright, and what you really want from this, though, this is our sequencing data. What you really want is the sequence, and to get the sequence, you click over here on chromatogram info. Alright, and this will grab your sequence for you. You can go look at details. One thing you want to know is the length, but you can also select all and copy, and that's actually what you want to do more than anything else. Then you want to go to like Notepad or Word or whatever, and you want to make a copy of your sequence. So in this particular case, now I'm in Linux, you don't have this, but I can just do this, create an empty document. Alright, call it my data or something. Alright, .txt or whatever you want to call it, and I can open that. You would use WordPad, Notepad, Word, whatever. I'm going to paste this in here, alright, and I'm going to save, alright, and I'm going to add that to my data. Let's see what I do with that. My data. So I'm going to cut this, and I have this. I'm going to add this in here. Alright, so I have my sequence here. Alright, I should also have a sequence associated with my primers. Oops, don't have that in this one. And I'm going to compare those in a second. But for this case, this is all you need for this part, is to grab this sequence and save it. Alright, and we're going to come back to the chromatogram and look at this in a second to see where our mutations are.